The clip you're about to see is on assembling the Arduino Nano to the microwave control board so that it controls the relay that's on the back of the board. Now each one of these is a little bit different. Now the reason I put together this video is so that you can see sort of as I'm going through the process some of the stuff that's involved in tracing out a circuit and troubleshooting issues as they arise. Please understand, if I'm not working in a professional context, if I'm doing something sort of as a hobby, my safety practices aren't really up to snuff, so to speak, with what they would be if I were in a professional environment. So when you're going through this video, keep in mind that it's for entertainment, informational purposes only. Don't do the stuff I do. Don't just mess around with probes on a live board that's not anchored very well. Enjoy this for what it is, and hopefully you'll get something out of it. The next part of the process is to use this relay, have the Arduino turn this relay on and off. This relay is going to be a 12-volt relay. They just don't make that many 5-volt relays that will power a microwave oven transformer. There's two different ways to do that. One of the ways I can do that is finding the component that controls the power to this relay and then just replacing that component with our own relay contacts. The second way to do this is if I power the Arduino from this board so that it's got the same voltage reference, and then I find the control signal for the relay, I can just have the Arduino supply that control signal. As long as the control signal isn't at like a weird voltage level, it would actually be better to do that. Looking at the bottom of this board, these two pins are for the coil of that big relay. One of these pins goes through a little jumper down to this plug, which if we go back to the wiring harness, we'd see that these two pins go to the door switch and then up to the common for all the relay. So basically this is going to be the part of the relay that isn't switched by the circuitry. This part of the relay follows this trace up to a transistor. This is the device on the board that actually does the switching. What I'm going to do is replace it with the contact points on the relay board and then just bridge this together, since we don't actually have a door anymore that we need to have closed for this thing to work. These lower two pins are the ones that we're going to bring over to the relay control board. We're going to stick one into the common, one into the NO for normally open. This third pin snakes around and goes up to the microcontroller on this device. Now I'm going to give everything a sanity check before I test it out. I've got the connection for the relay just floating so that it's not going to turn on the microwave transformer yet. If I've got everything wired correctly, since this is a 12-volt relay, I should be seeing somewhere between like 10 and 14 volts coming across the contacts of this relay when it's not switched on. So I'm going to turn on the power and test that. So when I check this out, I don't actually have that 15 volts coming across these two pins. To debug this, I turned on the actual cook cycle of the microwave and found that the voltage is present. So the issue was the voltage wasn't actually coming in because on this microwave circuit there's a fan that turns on, and when the fan turns on it supplies power through this diode that enables the cook cycle to even turn on. By removing the diode and instead sticking it here where it supplies power to this to where this transistor used to be, is able to fix the problem. With the wires connected to the relay in the back of the microwave control board, this switches on and off the transformer. I've shown this because it works and it sort of demonstrates the concept, but it's really sloppy at the same time. The whole purpose of keeping a relay board like this around, a microwave control board like this around, is to be able to use all the relays that's on it, be able to use the power supply that's on it to power this, so that I don't have to go and design a PCB board and order parts and basically reinvent the wheel. So we'll see if we can do this a little bit better. We're going to start by going online and looking up this chip by the chip number seeing how many volts it runs off. If it runs off of 5 volts, then there's really no reason for me to be using this 5-volt charger connected to the Arduino. I can just plug the Arduino right here. And then I can look at which signals that are coming out of this chip, turn on the relays. Apparently this chip is a microcontroller that can run on anything from 2.7 to 5.5 volts. Also got the pins that power is going to, so let's see what sort of supply voltage this one's running at. It's like 5.5 volts, so that's able to power the Arduino. Next, with the circuit off, I'm going to trace back from where the signal would usually go to the transistor that I pulled. Make sure I've got the right pin. So this is the signal that's coming out of the microcontroller that's turning on or off that transistor. Then with the power on, I'm going to see what logic level that is. So it looks like when this relay is off, it's at 5 volts, and it's got to be brought down to 0 volts to turn on. I inverted the logic level in my code, so D13 was pulled to 0 to activate the main relay, and put the transistor I had removed back where it was. I connected the Arduino power supply pins to the power pins of the existing microcontroller. I connected pin D13 from the Arduino to the trace from the existing microcontroller pin that controlled the main relay. Sometimes I would have to remove the existing microcontroller to keep it from interfering, but on this board there was a jumper that I pulled to accomplish the same thing. The design worked, but it had a flaw. Whenever the board was turned on, the main relay would briefly activate. This was a timing issue with the power signals. The power on the microwave board would turn on before the Arduino turned on, so the microwave board briefly saw a low-level signal when the Arduino was off and activated the main relay. The microwave board just happened to be designed so that the fan relay did not have this timing issue, so I returned the diode I had moved to its original state, where the fan relay enabled the main relay, and then used the Arduino to turn the fan relay on after a delay. To make troubleshooting and wiring easier, I removed the microcontroller and display. Now when the board powers up, you can hear the fan relay turn on after 1/10 of a second, and the main relay stays off until the button is pressed.